I think my real interest, if I traced it back, was curiosity about the physical world, which is what physics is.
One might imagine, at least, that one's talking about nature when one's talking about the character of physical laws. But I don't want to talk about nature, but rather how we stand relative to nature now. I want to tell you what we think we know, and what there is to guess, and how one goes about guessing.
This is the piece of the equation which describes how the Higgs field acquires its value.
So welcome everyone. Welcome to this edition number 57 of Physics Matter Colloquia Series on Development. So my name is Christine Darwin. I work at the European Spallation Source, the ESSO in Sweden, and I'm the former chair for the Forum of International Physics, the FIP at the American Physical Society, which support this series. So our Physics Matter monthly colloquia brings together a global audience, so for accessible, engaging science communication. So this series is dedicated to promoting capability building in developing regions and highlighting the importance of large-scale research infrastructure, such like the Sesame Light Source, so in Jordan. So this month, we will continue our virtual journey across the African continent. So in June, we were live from Morocco, following an inspiring international event in May that brought together the students from around the world. So in the months ahead, we will be visiting South Africa, Cameroon, Ghana, with other special events, planned in November as part of the African Strategy of Fundamental Physics and Application. So we will then close this year with a session featuring Professor Anna Maria Cotto, who is the chair of the steering committee for the International Year of Quantum Science and Technology. So that's going to be broadcast live from Mexico. So it's a very rich and engaging program, so you can follow all of that at your convenience through our website and our YouTube channel. But today we are live from Benin and Congo, Kinshasa. So we will, I think that, Professor Thierry d'Almeida is back now in Benin. But we are honored to welcome you, so to have also with us, our panel. So in the panel list, we have the honor to have Andrea Lossi, who is the scientific director of Sesame. We have also Stéphane Kenmore, from the University of Wisconsin, who is also the editor-in-chief of our FIP newsletter. And Munia Lassiria, who is from Brookhaven National Lab, in the US, who is also member at large of the FIP. So today, Professor Thierry d'Almeida, who has been, a short introduction. So he's a research director at the French Atomic Energy Commission, the CEA, and he's an international recognized expert in material science, in shock physics, in X-ray technique, and scientific instrumentation. So his extensive career includes position at the Washington State Institute of Shock Physics, at the European Synchrotron Radiation Facilities in Grenoble, at the University of Cambridge, before he's joining the CEA in 2010. So Professor d'Almeida regularly contributes to international higher education and research development, including expert mission, from institutions such as the National Research Foundation in South Africa, the CNRS, that's in France, the African and Magalese Council, for the higher education, and he's also advisor for the French Parliamentary Office for the scientific and technical assessment. So in the recent years, his work has focused on the design and implementation of training and research programs that address key African priorities. So including sustainable material, energy efficiency, environmental transition, and food security. So we are really honored to have you today. And we will let you speak after 45 minutes. You will have all the time to ask questions to Professor D'Almeida. You can use the section Q&A at the end of your screen. And so Professor D'Almeida, so the screen is yours.
Thank you. Thank you very much. Thank you very much, Christine. First, I would like to thank the organizers for giving me the opportunity to communicate on this topic, which has been a concern for me for many, many years now. I would like to make a personal statement as an African and as an African scientist. It is very distressing and sometimes painful to see that Africa is always referred to as a poor continent. Indeed, Africa is not a poor continent. It is endowed with immense natural resources. But unfortunately, for these resources to be transformed into wealth, into prosperity, and into social well-being, human being must play their part, I would say, fully. But Africa is not poor. So material science is actually, so I will start sharing my screen and hopefully everybody will see my screen, because if you don't see it, that will be too bad. So let me, I think I can, sure. Yeah. So can you see my screen now?
It will, yes, perfect.
Okay, good. So yeah, material science is closely tied to the continent economic challenges and opportunities, and particularly regarding the sustainable use of material and the value addition that can be introduced, the high value addition that can be introduced in its abundant natural resources in Africa. Unfortunately, many African economies rely on the export of raw materials, such as oil, gas, copper, cobalt, gold, etc., diamond. And over half of African countries depend on these commodities for at least 60% of their export earning, which make their economies highly vulnerable to global market fluctuations, to instability, to price cycles. And this dependence on raw material export without sufficient local processing of value addition, let's say, limits economic diversification and growth potential. That's one very important thing that we should have in mind regarding the wealth, the so-called wealth of Africa with all these minerals. So my talk will actually focus on, will be divided in three sections. First, I will give you some elements of context, let's say. I don't mean to be too statistical, but I think that we should give a little bit of statistics, because it's very important to have those figures in mind. So I will discuss a bit about the challenges that we're facing in terms of a skilled human resource shortage in Africa, but also lack of infrastructures and, you know, the challenges that you know, but it's very important to put figures on those and to give specific examples so that people can have a good understanding of what we're saying sometime, what we say sometime in a more general way. But there are opportunities, and I will discuss those also with specific examples, and try to quantify the needs in terms of resources and infrastructure. And stress a little bit about the strategies that can be put in place, and some strategies that are already in place, and some are working, some are not working so good. So all this has to be fine-tuned, adjusted for the future. And I will cite some, I will call them virtuous initiatives across the continent that are inspiring, even if they are most of the time at a short scales. They can be expanded, because good practices can be expanded and scaled up in order to have more general, more impacting, let's say, policies when it comes to science and education, and specifically material science in Africa. And I will talk about some of the predictable impact that we can foresee for these initiatives. Okay. Now, today with a population, this is the statistic part of my presentation, with a population of 1.5 billion, Africa represents about 18% of world population. This is significant, and about 60% of total African population is under the age of 25. And in some countries, like the Democratic Republic of Congo, this figure rises to 70%. 70% of the population is under the age of 25. It's a huge challenge. It can be a huge opportunity, but as I always say, this can also be a time bomb if the right policies are not in place. So that makes Africa the youngest continent in terms of population structure globally. It is also the region of the world where the population is growing the fastest. So much so that in 2050, Africans will represent 25% of world population. And by the end of the century, if we follow the same trend, it will rise to 40%. So this demographic dynamic could constitute a formidable force if it were followed by wealth creation in equivalent proportions. But what is the reality? The reality is that currently, with 18% of the world population, Africa only accounts for 2.8% of global GDP. And projections for the end of the century are hardly more promising. Projections for in 25 years from now, let's say, by 2050, are hardly more encouraging and promising, because Africa will only represent 7% of global GDP. And even if you adjust this figure by GDP, what they call purchasing power parity, we see that the gap remains considerable. So we see that contrary to certain very optimistic assertions, when I hear some politicians speaking about the growth, formidable growth, etc., you have to understand what it really means. Because in reality, the impoverishment of the continent risk worsening if nothing is done to reverse this trend. Now, all this seems, I would say, paradoxical when we compare it to the reality of the continent in terms of natural resources. Indeed, the continent is immensely blessed by nature. Just to give you a few examples, Africa is one of the world's richest continents in terms of natural resource. We already say that. Look by yourself, oil, gas, and coal. Actually, you have the same figure for oil and gas. You have 12% of world reserve, and for an 8% of reserve for the coal in Africa. In terms of potential, agricultural potential, 70% of world's arable land is in Africa. And in some countries, like again the DRC, Democratic Republic of Congo, you have 80 million hectares of arable land that are not exploited. And that these figures really, when I realized that, and I went to check and check and check again, and that's something that is just very distressing. And in terms of renewable resources, you have 10% of internal freshwater sources in Africa. And when it comes to forest and timber, 25% of world remaining forest. So I could go on, the list goes on, I could go on and on and on. Wildlife, same thing, fisheries, same thing. The list is very long. Now, why is that this is not generating riches? I'm not an economist, and actually we don't need to be very familiar with economics to understand that a major cause of this paradox is actually the weakness of the industrial capabilities in general, and more specifically, the weak capacity to transform natural resources into high value added product. Now, the bulk of value addition to raw material lies in the transformation, of course, which is associated to the secondary sector. And as you can see, the secondary sector only accounts for the 13% of Africa's GDP, which is much, much, much lower than in any other region of the world. And this very low industrial base has many root causes, among which the rules of the credit market. Of course, if you want to borrow money from a big bank, and if you are from Africa, you will have rates that are just that are totally discouraging. And if you want to borrow, and if you live in America or in Europe, of course, you won't borrow at the same conditions. So that's one of the reasons. Second reason, very important, is the access to energy. In fact, energy insecurity, we can call it like that, and underdeveloped logistic network hinder industrial growth. But one of the major causes is actually the lack of qualified human resources and skilled human resources. And in few minutes, I will quantify this for the engineering sector in general, but I will try to quantify that also for the material science sector. And these figures have been cross-compared and with other figures, and you will tell me if it makes sense or not. We can discuss. So by processing commodities locally, Africa can earn more from its export and reduce its dependence on exporting raw, low-value goods. And the industrial sector turns out to be the main conduit for skill development, knowledge transfer, and innovation. Now, there are, of course, a lot of challenges. So, as I said, added value is something that has to be introduced. Let's have a look at the key benefits that could be introduced in Africa's by engineering and processing materials in general. Of course, they include human capacity building, increased research capabilities and output, significant rise of market value, industrialization, increased economic value, job creation, and community empowerment. All these are, of course, benefits that can be obtained if the right policies are in place. I'd like to give you a few specific examples about the opportunities and avenues in order to create value. And you will see that material science is present everywhere. We all, I think we all like chocolate. So it's not a digression. I'm just telling you that chocolate is a striking example of economic losses in Africa due to the lack of processing capability. that is everywhere. If you take Ivory Coast, one of the main producers of chocolate, there are very little capabilities for transforming chocolate and cocoa into chocolate. The global chocolate industry is valued at around 130 billion, and it's rely heavily on cocoa as its key ingredient, of course. Nobody likes chocolate without cocoa, but there are some chocolate without cocoa. But cocoa is the main ingredient. So the global chocolate market was valued at 130 billion. That was back in 20. These are the last figures, by the way, 2024. And it's projected to reach 173 billion in 5 years from now. So that's pretty steep. Cocoa beans are the raw material that is harvested by farmers who typically receive the smallest share of the final revenue. In fact, the transformation from bean to chocolate involves many intermediate steps. You have to process, you have to manufacture, you have to brand, you have to retail, and all these significantly increase the product value and price. Those are at the top of the supply chain. The top of the supply chain are the ones who capture most of the added value, while producers of raw cocoa beans earn comparatively much less. And by the way, producing good quality chocolate involves crystallography. We can discuss that, but that's not the topic. So chocolate, it's a nice example. And now I will speak about other products that are quite emblematic. Take, for instance, bauxite to aluminum. And that's something that we have to, and one of the top producer of bauxite in the world is Guinea in West Africa. But there's no capability for processing bauxite in Guinea. Not even to the first step, which is alumina. And this is the only country, it's a top producer, but it's the only country that does not process its aluminum. The second producer, as you know, is Australia. And then you have China. And in fourth position, you have Brazil. Brazil has been developing its processing capabilities at least to the alumina level. So aluminum, as you know, is a versatile metal used in many applications due to its unique properties like low density, high strength to weight ratio, corrosion resistance, excellent conductivity, and so on. It is found in almost in many sectors, construction, electronics, many consumer goods. So national effort in alumina production, which is just, as I said, one processing step away from raw bauxite, can add 10 to 20 times the value of raw bauxite. So do you imagine you will multiply your gain by 10 to 20 just by one step of processing? And this has been exemplified by countries developing domestic alumina refining capacity rather than exporting raw ore. And this market is expected to grow again due to the increased demand for lightweight materials in electric vehicle and sustainable construction, alongside innovation in production and recycling, etc. So that's one example that really it's quite striking. You have also another sector of very high potential in terms of added value. It's the timber sector. In fact, I always say that Africa should be leader in sophisticated carpentry and timber construction, because look by yourself. Africa, of course, is the continent where you have essentially most forests are remaining in Africa. You take, you know, the Congo forest and other places in Central Africa. You have a lot of wood species that can be exploited, and whose exploitation is not detrimental for the environment. But still, you know, it's a distressing example, because the failure to develop these capabilities result in a lot of losses, result in large trade deficit, missed opportunity for job creation, lack of wealth generation, no industrial development, and formal timber export accounts for 17 billion. That was, again, last year. This year, the statistics, of course, are not available yet, but at the end of the year, we'll have them. I'm sure it's growing. But alongside that, you have illegal timber export, ranging from 50 to $150 billion annually. So just imagine the loss of riches that these introduce in Africa. Now, this shortage, we discuss the needs in the next few slides. A shortage in human resources and in infrastructure are specifically critical in the engineering sector. The lack of engineers in Africa is a huge challenge affecting the continent development. Sub-Saharan Africa is estimated to require additionally 2.5 million more engineers in order to meet its pressing development challenges. And Africa, as you know, has the lowest number of engineering professionals per capita globally, which we've estimate, let's say, of less than one engineer per 100,000 people in sub-Saharan Africa. If you compare that to about 500 engineers per 100,000 in Europe, you see the gap by yourself. For example, in Tanzania, with a population of 67 million, which is roughly the population of France, Tanzania graduates only about 1,700 engineers annually. Very insufficient for its growing population. Benin, my home country, with a population of about 12 million, graduate less than 200 engineers annually, all sectors combined. So these are these are the facts, actually. So the potential impact on economic growth is something that we can discuss and we can benchmark with other regions of the world in order to have an idea of what could be generated in terms of added value, in terms of riches in Africa, if we could increase, if we could reinforce and build capacities in those fields. I did a small benchmark using other regions of the world. So let's, if you want to quantify a little bit this, the impact of the second categories of workers. So as I said, look, what are the key drivers of demand? The key drivers of demand are essentially three sectors. You have infrastructure, urbanization, the building, let's say, the construction and maintenance, and roads, bridges, and power plants, etc. And the second is the industrial growth and natural resource management, which include processing, refining, and that in this category that material scientists fits, actually. And the third one is energy and utilities. You also have a lot of material science there, but you will see with the example that I will be giving now. So let's look at the second category of the key sectors that I just showed you, the one related to industrial growth and natural resources management, processing, refining, etc. It's a category of engineers in the resource processing sector, and that's exactly where material science fits. Now, studies from other regions of the world, especially I took one example in the United States, the state of Arkansas. There was a study in 2022 showing that increasing the share of engineers in the workforce by about 1 to 1.1% can boost GDP per worker by approximately $3,000, which which is a very significant number, and this really generates job creation and overall GDP growth. So this has been this is a very careful study that was published in 22, and that was republished in the World Bank report in 2023. You have the references there. So using this as a rough benchmark, several studies, mainly again from the World Bank and the African Development Bank, have suggested that if sub-Saharan Africa increase its engineering workforce by 2.5 million, as it recommended, the potential GDP growth per worker attributable to engineering expansion could be substantially and possibly could be substantially increased, possibly adding thousands of dollars in GDP per worker over time. So if we apply the results of these studies to the scale of the material sector in general, we can deduce that increasing the number of qualified engineers in that sector, and technicians, of course, by around 400,000 per year over the next 10 years would have an impact. This is all sub-Saharan Africa. Will have an impact of around 2% on the economic growth of sub-Saharan African countries. And that is something that, I mean, should be made known to the policymakers, because this is a lever on which we can really can really benefit economics in general. Now, what are the strategies? Oh, I just missed one. Just excuse me. Yeah, so that's a potential impact. So of course there are a lot of techniques involved. So you can see job by job, techniques by techniques. What are the jobs that can be that those techniques that are required can generate? Of course, you have to be able to compact the materials. You don't just send raw ore. You don't just ship it as it is. So compacting is very important. Binding the raw materials into more, let's say, manageable granules for subsequent manufacturing steps. So that's, at least that first step is something that can introduce a lot of know-how in many African countries. And of course, you have a lot of chemical processing for metal and synthetics, refining, and chemical extraction techniques such as the Bayer process, which is very important, you know. And of course, these the related jobs are and skills are found in chemical engineering, processing engineering, material science, environmental engineering, etc. Now, what are the strategies that can be put in place, and are they put in place? And can strategies and can some policies be considered as good practice, and can they be expanded? Of course, you have to be able to reform engineering, the way that engineering is taught in Africa, the way that the schools are organized, the way that the know-how, the knowledge is transferred, is something that should be revised in many disciplines. So curricula must be reformed in order to be more relevant, responsive, aligned with global best practices. It's not always the case. As a teacher, when you're teaching students at the master level, and you realize that they don't have any practical skills because they've never been in a lab, and you want them to be engineers in a few months, you can see that it will take them a long time in order to be able to be operational and to be able to be productive. Of course, some of the teachings, some of the program must be contextualized. It's very important to be able to contextualize and to emphasize also the lifelong learning in order to update the skills of engineers continually. One of the things that you notice in Africa is that once you get your diploma, your degree, it's over. You don't learn anymore. You don't update your skills. And that's something that is creating a lot of, you have to build a partnership. But of course, always speak about partnership with North countries, but South to South partnerships are also very relevant. I was recently in some South, let's say, countries, the global South, I mean, and you can see that some of the experience that were developed in those countries are very relevant to Africa. So these partnerships, but there's almost no link, no connection between countries like African countries and countries like Brazil or India, and even some French islands of, let's say, overseas islands like La Réunion, where they have excellent programs for processing materials that you only find in tropical regions. So this has to be encouraged. Of course, we have to develop regional academic networks. It's painful to see that, for instance, in Benin, you have very little connection with the sister university of Lomé, which is just an hour or an hour and a half drive from Cotonou. There's almost no connection. So these regional academic networks must be developed, have to, of course, invest in modern equipment in order to be able to train our students, but also to do research at a normal level and to have a scientific output that meets the standard of global scientific practices. And of course, in order to get the financing, the funding for all these, the public-private partnership is something that has to be developed more. Now, there are, of course, very good examples. I would like to cite a few of them in Africa of initiatives that are already proving to be very productive, very promising. I'd like to cite a few. There are important initiatives that collectively target capacity building, applied research, aligned with Africa's mineral and other natural resources, but also infrastructure, energy, manufacturing, tailored to African needs. These initiatives, of which you can see some example here, are already proving good results. You know, we've probably heard of, some of you have probably heard of the so-called PASSET initiative. It's called the Partnership for Skills for Skills in Applied Science, Engineering and Technology, PASSET. This is a Pan-African initiative that was launched in 2013 by African government. Initially, it was Senegal, Ethiopia, Rwanda, and later they were joined by other countries like Kenya, Ivory Coast, and I think there are other countries now. And the mission is to strengthen science, technology, engineering, and applied science capacity in sub-Saharan Africa, to drive long-term economic growth and structural transformation across the continent. And the initiative focuses on priority sectors, including mining, agriculture, infrastructure, and aims at training approximately 10,000 PhDs over 10 years. Okay, it might seem not very ambitious, it's reasonable, but it's good to do, to have very definite objectives and to reach them and then to scale up when possible. You know, the JUAMI initiative, I think JUAMI stands for Joint Undertaking for an African Material Institute. It's a collaborative initiative that was established back in 2012 to foster material science initially it was between Africa and the United States and other global partners. So the JUAMI initiative have benefited over 300 early career researchers, mainly in Kenya, Ethiopia, and in the United States. There are other initiatives, but I would like to cite a few of them, and next we'll be able to discuss a bit about the achievement of these initiatives. You have the Pan-African Institute, Pan-African Materials Institute. It's called PAMI. It's an African University Institute in Nigeria. It's a West African Regional Center of Excellence, which is funded, by the way, by Nigerian government and the World Bank. So PAMI trains material scientists and engineers with focus research group and on energy devices, solar cell, etc., water filtration, mineral processing, corrosion to deal with the corrosion, and sustainable building material. And you have others. You have Marol, the ARUA, which is the a material center of excellence, also in a center of excellence in material, energy, and nanotechnology. It's hosted by the University of Wits in South Africa, and it links multiple African universities, and it aims really to be being a hub for material science research and training with a specific emphasis on materials development relevant to African context, such as off-grid energy, recycling, mineral, etc. You have the AMSEM. AMSEM is also a network that was established in 2008, involving multiple African universities, including the one of Wits, Botswana, Ghana, Nairobi, Namibia, Nigeria. And you will notice that these are English-speaking universities. This is also a weakness of the system. There's not much connection, very few connection between English-speaking universities, English-speaking academics, and French-speaking academics. Not much connection with Portuguese-speaking academic, and this is something that has to be addressed also in order to deal globally with those challenges. In fact, I do believe that individually, African countries are just too weak to develop significant training and research capabilities. They have to try and mutualize things and build poles, in regional poles that can be used and mutualize, of course, the funding in order to have significant capabilities that can benefit all the continent. And this is such initiative that was developed. The last but not least, of course, is the XTech Lab platform, and the XTech Lab platform in Benin, whose genesis actually and ambition, by the way, are directly linked to the African Light Source project. Indeed, the XTech Lab is a feeder facility for these large experimental platforms in the world, because it trains and and it trains scientists, graduate students, teachers, in order to endow them with practical skills, practical and analytical skills that are necessary to address challenges they are facing. It's an experimental. It's an experimentation platform. It's not experimental. It's an experimentation platform which aims at developing a new model or for a collaborative training and research system focused on solving critical problems on the continent in Africa. And again, I'm making a little focus on the X-Tech Lab because it's a platform that is very dear to me. The X-Tech Lab has a material science program that aims at developing specific programs, and one of them is on sustainable building material. And the motivation is quite clear to develop those. Economic construction, you should know that the market value of the construction market is 230 billion. That was 230 billion in 2023. 2023, 230 billion. And unfortunately, this market does not benefit much the African countries because most of the models are imported. Raw material, local material are not exploited as they should be. And that is something that penalizes the economy because a lot of money is being spent to, of course, develop those infrastructure, importing materials, building an habitat that is not adapted to the conditions of the environmental, the climate of Africa, and that will become a huge issue in the next coming years with growing. Actually, it's foreseen, it's projected that in 2050, more than half of the African population will be living in cities, let's say, at least in urban areas. But when you mean urban, it's everything. It means, of course, decent cities, but it also encompasses other realities. You have a lot of slums being developed here. And the concrete is just everywhere. And that is something that is actually distressing because we have plenty of resources, of materials that can be exploited, that can be processed, that can be revisited in order to develop more suitable construction in Africa and minimize the environmental impact, the footprint, the environmental footprint, using those materials that are more adapted to our reality. So the overall objective of this program is actually to revisit local material in the light of the most advanced scientific tools and methods in order to improve their properties and extend their use in modern building. So that's something that is done with a well thought through methodology. You have to develop innovative and sustainable material based on rigorous experimental and digital validation processes. Of course, the method include X-ray imaging, tomography, it includes morphology extraction, it includes numerical calculation, it includes thermal characterization, mechanical characterization. All this is used in order to come up with new material that will be tested, validated through standards in order to be used in modern construction. People want to have modern houses. They don't necessarily want to go back to small houses as it was used to be. It was constructed and to be built 500 years ago. But all this now can be done if material science is used as a tool to improve the properties of those materials. And to do that, again, one very smart thing to do will be to get inspiration from people who have the same realities and who have developed good practices. And that's something that is being done now and that will be done in the near future through collaboration. But I will come back to that in few minutes. Now, of course, there are some achievements of the X-Tech Lab that focus on sustainable building. There are some achievements. So far, there have been 8 training sessions, and these sessions are open to all people across the continent. They are supervised by the best available scientists that we can have around the world, come from many countries. And so far, we've been able to train 200. They've been able to train 200 learners from many different African countries, you know, and more than 100 different samples have been characterized. The idea is that people come with their samples, with their project, and through the guidance and the supervision of some of the best scientists that are present, physically present, a new shape is given to the project, and they are supported so that they can actually have good scientific output, publication, and patent, etc. So physical properties, chemical composition, microstructure, thermomechanical behavior, all this is carefully studied in order to reach to gain insight into behavior, to improve design, and of course, to diversify applications. So I already discussed we discussed the construction material, but we should talk about the sector of timber. The timber is, as I said, one of the emblematic example of losses that are being experienced. The trucks that you're seeing on this picture are probably heading toward a harbor and will be shipped out of the continent without any processing, as it is. And something that this is something that really is a shame. So at the X-Tech Lab, there are studies, ongoing studies of local wood species in order to extract the information to understand the behavior of those materials, to improve our understanding of the microstructure. The teak wood, I don't know if you're familiar with that wood species. It's a very good species that is used for construction and in many, for quality furniture. It's one of the best woods, best species in the world. And X-Tech Lab has been working to optimize the rotation cycle and increase value of local production in Benin and in neighboring countries. The idea is to design innovative wood-based material for various applications. And again, to do that, we can get some inspiration from what is done, for instance, in Brazil. I would like to mention the very good work that is done at the university, the University Federal of Rio de Janeiro, the Federal University of Rio de Janeiro, and especially in the NUMAT lab. Getting inspiration from what they do there, establishing partnership is something that can lead to significant output in the very near future. This is an example of a collaboration that was carried on a few years ago, 3 years ago actually, between Benin and École Normale Supérieure de Paris, ENS, and they were able to produce a very nice paper that was published in 2022. And all this is using tomography, using various experimental techniques in order to characterize the wood and understand its property, its behavior, and of course, upgrade and in terms of the potential of application. These are slides that were that I show you with the courtesy of the NUMAT. They're doing very innovative wood-based materials in Brazil, and I would like to thank, by the way, one of our colleagues who is originally from Benin and who works in that in this lab and is carrying out very nice, very nice work in order to valorize these materials for construction, these available resources. And the work that he's doing there will be extremely valuable if one day he decides to get back to Benin. But even if he stays there, I think the collaboration and the partnership that can be put in place is something that will be very profitable. They use wood waste with cement paste in order to come up with innovative, sustainable material for construction. These are wood-based composite and wood biocomposite. I was able to see that it is very beautiful. They do the same thing, actually. I would like to show you the next slide. Yeah, they do the same thing with, again, wood is a material that is being processed at a level, unprecedented level, that is being exploited to actually to produce value, not only to produce riches, economic riches, but also to come up with innovative, sustainable material, because it's a responsibility of science to protect our planet and to come up with alternative materials, because the way we've been exploiting those materials for the past, the recent past, is something that is not sustainable. You know, in my home country here, many houses are built in concrete, and if you don't use air conditioner, you cannot live in those buildings. It's just impossible. So you have to use air conditioner, and the materials are available to build high quality housing just by exploiting the resources that are available. But science and material science must be at the service of these projects. I would like now just finish my talk by some conclusion and prospect. Material science and engineering can significantly impact economic growth. I haven't given you half of the example that I've collected so far, but we can discuss some of them. Engineering education fosters critical skills that support Africa's economic growth and innovation. Material science and engineering underpin the development of manufacturing industry, which is essential for shifting African economy from raw material export to value-added production. And material science and engineering serve as pillars for economic transformation in Africa by enabling industrial diversification, fostering innovation, improving productivity, creating skill jobs, and foundational infrastructure that are critical for sustained economic growth. Thank you very much. I've slightly exceeded the time which was allocated to me. I would like to apologize for that, but thank you very much for listening to my presentation.
Thank you very much. So, Professor D'Almeida. So we have really, I greatly appreciate the diversity as well of your talk, like looking at the social, economical, setting up the context, and then giving those examples, which I think are extremely valuable to see how education, but as well this entrepreneurship and this capacity to build as well. So for the innovative, sustainable material. So how to adapt to the environment. So we have quite a few questions, and you can go on and ask more. I would still like to start with my colleague, with Andrea Lossi, because I really like the example that you gave from X-Tex Lab as well. So with the idea as well of collaboration potentially. So maybe I leave the words to Andreas, that I think has appreciated as well.
Yes, well, so splendid the presentation. Thank you very much. And I also take chance to say hello to Marielle Hugbata, who is, I see, is in the audience, and we met in Trieste at ICTP once. And so I was wondering how much is the impact so far, and how much is the possibilities that how the African countries can leverage the International Decade of Sciences for Sustainable Development, so to transform basic science from academy into innovation and growth.
Yes, I mean, the impact so far, I've given some examples of few initiatives that are encouraging, but they have not yet reached the critical mass that is required in order to induce transformation. Look, we're talking about 2.5 million scientists that should be trained. But look, if you look at the statistics, we're far, far, far behind because all these initiatives are isolated most of the time. You have a country like Benin. Benin is a small country. And as I said, if there's no mutualization of effort, if there's no collaboration, if there's no partnership, it will be extremely difficult to have impact. Training 200 scientists in a specific field may make a little difference, but it won't make a big difference. We need large experimental facility, large experimental programs. Just before my talk, we were discussing Sesame, and I wanted to tell you, look, this is something we need because you will be able to gather in a facility like that a formidable diversity of profiles, of talents, and we all know that new things, innovation always occur at the intersection of disciplines, at the intersection of experiences, of cultures. We need those things. But in order for us to have a light source facility or a large experimental facility, it has to be something that is done collectively. It has to be a collective effort. That's where scientific advocacy is very important. Because most of the things, the genesis of the X-Tech Lab was a nice example of how to be able to reach the attention and the interest of policymakers. Because if you come with some general ideas of we have to put up establish a large experimental facility, yes, but they will say, okay, well, yeah, that's very good, but yeah, let's do it. But if you find a way to touch them with and to show what will be the interest of having the X-Tech Lab for Benin is very important. It reveals Benin on the scientific map. There are people who didn't know. We had people, learners from Ethiopia who came and they told me that they didn't know about Benin. And that's something that policymakers can be sensitive to. Anyway, to keep the story short, I think that impact will occur with mutualization in order to reach the critical mass that is needed, that is required to have impact. Right now, all these initiatives are too isolated. They are not thought through as in a global strategy that with predictable result, with planning, with plans, with targeted objectives, short terms, mid-terms, and long-term objectives. We have to, these 2.5 million for a continent of 1.5 billion people, is an objective that is achievable. It's a reasonable objective. But in order to do that, policies must change. Yeah.
And I think this is the
Yes.
point. Policy together with research infrastructure and like all those development, as you mentioned, and the education. So this ecosystem integration everywhere of this will. So you mentioned about engineering and scientists, and indeed we'll discuss in November about this African strategy for the fundamental physics and application, which might be Munia. So she's our spokesperson there. So be very relevant for that case and for that topic.
Yeah,
So
actually, okay,
go
so
ahead.
I'm
I
not
mean,
sure if I can, okay,
please
I
go
can
ahead.
speak. All right, thank you. I'm not sure if you are already aware about this African strategy for fundamental and applied physics. Like, I mean, we are now working toward finalizing the final report, and the symposium is scheduled for November. So where we are going like to present it to the international community for final feedback. And I believe, yeah, you are all like invited to participate in this great important event. So also, I would like also to mention that this report, the ASFAP strategy, has received the endorsement from the UNESCO, which will facilitate distribution of this report to its member state to support implementation efforts. So yeah, also as Christine did mention that on November 20th, we will hold a joint session dedicated to this in physics matters. And so yeah, with this upcoming open symposium in mind, how do you see the role of material science evolving within our continent, in particular, like how can it help foster collaboration and resources sharing to accelerate research and innovation across Africa? You did like mention those great initiatives, including the XTech Lab. I'm not sure like if there is any collaboration between at least the neighboring countries close to Benin to help sharing the information and knowledge.
Yes.
Yeah.
There is collaboration. No, good. Thank you for your question. It's a very good one. Unfortunately, I was not aware of that initiative that you just mentioned, and there's a lack of communication because there's a lack of we don't create the communities. That is something that we're not very good at. We have to be able to create the communities, the platform, and exchange. As I told you, there is some sort of compartment between French-speaking people and English-speaking people. It is ridiculous. Nigeria is just next door to my hometown. Porto Novo is a few kilometers away. But there is almost like, it's easier to go to Paris than to go to Nigeria. And that's something that, that's just the reality. But really, I think that the role, material science, in my opinion, has a very important role to play. I was building partnership between some French universities and Democratic Republic of Congo. And one of the things that really changed their mindset is that they realized, those French institutions, that it could also be beneficial for them because there are new avenues that you cannot discover until you have an experience with African material. Africa is a continent full of new materials that can be engineered differently. And new ideas, you can come up with new ideas, with innovative ideas to do new things that cannot be even thought of in the context of Europe or even America. There are in that country, by the way, the Democratic Republic of Congo, it's an incredible example. It's 2,345,000 square kilometers. It's a continent, And initially, when we started the collaboration with some Université de Pau, Sorbonne Université, Université de Lorraine, in Nancy. They came to the collaboration with goodwill, but their idea was just to help. And then they realized that for them, for advancing, they could develop cutting-edge research based on these new ideas that they come up with by having this experience in Africa with new material, new climate, different climate, new environment, etc. I think that it will make sense for us to build those partnerships at the African scale, at the African level, and try and collaborate more among ourselves, and so that I don't discover what you just said that will happen in November. I wouldn't have discovered it if I wasn't giving this talk today. So really, thank you very much. And you should establish contact, especially with those in charge of the X-Tech Lab. I think you may know some of them. Some of them may be online today. I was sitting Marielle Agbangbata, who is the coordinator of the platform, but you also have Sidwan. They work there, and I think they will be willing to establish those collaborations.
Very good. Yeah, Stefan, so I know that this is part of your interest as well.
Thierry, I will not blame Munia or the community about what just happened, because this is simply the consequence of the lack of investment or of funding in the science communication, right? There's a lot of investment on technical skill on the continent, but nobody cares about science communication. I mean, how to connect African physicists or scientists in general. I mean, even if you apply for, training in science communication, nobody cares, while this is the key on the continent. This was a comment. Now I have a question for you, right? So I want you to be frank and honest, right? Because you are very respectable, because you achieved something that many people for decades, since the 60s, after the independence, could not achieve. So I want you to share your recipe. How come that you were successful in Benin? Because the reality is that you had ideas, you knew how to connect the dots, you knew how to bring expertise to Benin, but you had the support of the politicians there, the decision makers. And then it was not a free or an easy support. You have to convince them, right? And then there were a lot of applications, among which yours, and then yours was taken. Of course, you had a good president who could understand what a scientist could say, who invested in City, for example. So this is what is needed, according to me, on the continent. Recipes, how to convince these political leaders so that they invest money, right, in science. So
yes,
this is something I've only seen in Benin with you, in sub-Saharan Africa. This is what I would like you maybe to share with the international community, because Italians, French people, Americans, everybody go in Africa for 60 years, but there's nothing. People should ask the question, what is happening?
You're right. Thank you very much, Stefan, for your question. And I will be frank with you. Actually, I don't think it's a merit. I don't think I was the one that induced these changes. You know, when some policies are in place, there are people that you meet that it's a change of mindset. There's something happened in Benin that led to the presence of people with a different mindset who were open to the idea, who understood that innovation was key to development, who understood that nothing in Africa could prosper, could be achieved without the contribution of education and science. And these are the people who were receptive to our ideas. And there are people from the government, people from the agency, the City agency, the director of the agency. These people were receptive to those new ideas. I think that is very important. And then, of course, you have to be able to find the few good people, dedicated people that have the passion to really change things. You know, so this from the institutional point of view, I told you that there was a new climate, a new environment in Benin that was established by this government. and by people around the government, in the agency, people leading these agencies, MSCT, things like that, that were open to these new ideas. So this is the policy. But then you have to have people like Marielle, like Sidwan, who are passionate young scientists that are not just interested in moving away from Africa, getting a good salary, because they could have. People like Francois Diolé, who is leading, at the Extech Lab, also all the spectroscopy effort. People like that are the one really that are game changers in Africa, because these are people who can transform things with a small drop of passion in what they do every day. And I was able to leave after a few years. I didn't stay in Benin. I spent 4 years in Benin, and then I moved on to other projects around the world. I expect to do the same thing in Congo. I expect to do the same thing in Kenya, which is now one of the focus of my intervention across the continent. I think it's possible, but sometimes, Stefan, we scientists, we speak a jargon that is not understandable by politicians, and especially politicians in Africa.
Yeah, so this has to do with science communication and engagement, right? So,
yes, hard communication. Okay. You have to communicate, really. Because I know that what you are doing, for instance, and I'm aware of what you're doing, is something that really can make it a significant change, because you're using innovative formats that were not used before. And this format, the way you present things, is also very important in the process of convincing the decision makers and the large public. Just give you one example, one specific example. 4 years ago, I think it was back in 2021 or 2020, I can't remember exactly, Marielle and Sidwan were able to reintroduce practical teachings at the University of Abomey-Calavi of crystallography. This was stopped 10 years before. So they went to that university with papers, how do you pave a way, what is the order, the crystallographic order that you introduce to pave the way. This was a very simple thing, and they managed to do it and to reach over 1,000 students. So they did this, and after doing that, it had an echo in all the university, and even today, people are citing these initiatives. That's how the crystallography practical teachings were reintroduced at the University of Abomey-Calavi. It takes a lot of passion, but it's possible.
So it is, and I think that you are the perfect example, but it's not easy. So this is one of the things, and sometimes this is chance to meet the right person at the right time, and then to find ways as well for the politician to be engaged, and to engage maybe as well then with the right funding. So you mentioned indeed the other initiative as well, with the role as well with the World Bank or with the IUPAP. I know that they do a lot as well, for instance, with the Extech Lab. So
you have to do a little bit of astronomy in order to align stars. If you align stars, it's fine. You manage to get through.
But we don't want to wait every 70 years as well to align the right star for Africa. So that's
I agree with you.
So the probability to train more scientists and engineers is both. So this is one of the big things. Now I will go for the question, because we need to come also to some of the root cause, which are the energy and all those aspects. I think that's a big one. So now reading the question also from Fallon, so asking about the abundant natural resource that you were mentioning. So it's widely recognized that the focus should be on developing qualified human resources. So the question from Fallon is, so what are the different ways in which qualified individuals, particularly those trained overseas, are supported and encouraged to reintegrate into Africa in order to help address the shortage of skilled professionals? Can you give few examples? The first question.
The first question, okay, I'm not sure if I understand well, but as I said, qualified engineers and technicians, by the way, and technician. What if you just invest in a high quality instrument that is installed very nicely and after it breaks down after 1 year and you have to wait for another 3 years in order to fix it? And that's an example that I'm not giving randomly because I know that this happened. I was at the University of Lubumbashi a few weeks ago in DRC, and I realized that they had 3 scanning electron microscopes. The 3 of them were broken since 3 years, and nobody could fix them. And I asked why the 3 of these instruments are broken at the same time. And they say that it's mainly due to the power failure that they have repeatedly. So this is an example of if you just invest in some equipment and you don't build capacities, you don't have a comprehensive training program of maintenance to train technicians that will maintain the equipment, and you don't have to wait for somebody from Italy, from the United States to fix the instrument, you invest in nothing. And as I said, there is this strategy, the critical mass that we need has to be designed to achieve reach the critical mass, but also to implement a comprehensive strategy. Develop equipment, have maintenance program, mutualize effort, join connect people together, and have a global strategy. Even in Europe, I worked at the European synchrotron back in at the end of the 90s. I started after my postdoc in the United States. I joined the ESRF, and already the European countries who were already much more advanced than Africa in science and technology, they felt the necessity to join, to be together, to have the ESRF, because it was impossible for France alone. Of course, they could build the facility alone, but to gather all these high top scientists from Italy, from Sweden, together at the same place called Polygon Scientifique in Grenoble, that was a huge achievement, and they understood that they had to go through that way. This is the kind of model of good practice that I would like to introduce in Africa. But the current mindset that we have in most African countries is that we have to do things alone. Senegal wants to have his own program. Togo wants to have his own, Cameroon and others. We cannot, it's impossible. We will not reach that critical mass if we don't mutualize effort, if we don't think collectively of a strategy to reach our objectives. That, by the way, needs to be defined, needed to be defined, this objective, because so far it's a nebulous, those objectives.
So it's a bit also, so the goal or what the organization or the African Union as well should be putting as well in one of the priority. So again, communication, skill, but it's also the frontier that exists in Africa that certainly are also really strong as well, and maybe sometimes impermeable. So in one sense, but then as you said, the French speaking and the English speaking country beyond the number, I mean the zillion language as well that you have within Africa. So there's a lot of
all
things.
is linked together. Like DRC, as I said, it's a huge country, but there's no road. So if you don't take a plane, you cannot go from Kinshasa to Lubumbashi or Kolwezi. So that's an example.
But that could be this is a national support. So this is, you have the more or less local to global. So it has to be like build up. So within, so everyone in the society. So I will go a bit faster, sorry, because indeed we don't want to take everybody's.
Yeah, I know that there are very interesting questions here. I can read in the chat, very good questions that I would like to answer, some of them at least. And
the second question, indeed, looking at, so Willis Benar, who is asking, Willis Benar Kira, asking about also the current state of material characterization facilities in Africa, particularly in the east of Africa. So he believed that exploring, so the exploitation, of raw materials, so without deep scientific understanding of their property is a major loss of value, as you said, so for the continent. So what step can be taken to build local capacity in this area? Thinking what you know about the east of Africa. Kenya, you were speaking about that.
Yes. East Africa, Central Africa, they have common realities. I think that one of the things that we should forbid is the absence of skill transfer. When big companies come and exploit a given material, you know that now we are in the process of the energy transition. And you know that materials that are critical for this energy transition are mostly in Africa, and especially in 2 or 3 countries, not more. But then you have companies that are there and that do not collaborate with local people, even with local universities. One simple rule should be that all of them host interns, that a master student or technician who must spend time in the company and access to everything and work with it. This is a simple thing that can be implemented. It should be a policy. But that if you are exploiting, I don't know, cobalt in Kolwezi, you should train students from University of Kolwezi. It's very simple. If you don't, then you cannot access. I'm sure that if you impose this, they will agree to do that. But just that it's so simple. The idea is so simple, to introduce this regulation, to just introduce this specific regulation, that would make a huge difference. To have interns spending time at in those big industries to understand the process and little by little reach an appropriation of the technology, the processes now it's one example out of many, but there are too many ways, very simple, practical ways to implement, to build locally capacities.
And also from overseas. So this is transfer of knowledge and having those internships. So this is good. Sometimes there is another thing that happened. For example, you spoke about the aluminum. It requires a lot of energy. So this is one of the other aspects and other challenge. So, and this is leading as well to the question of Camille Quebec, who is asking, so making your map of the natural resource that you mentioned, uranium located in South Africa, Namibia, Guinea, lot of different countries as you showed. So he's aware as well that more or less now speaking about nuclear power plant, because this is what could bring the biggest source as well and quantity as well and of available energy needed for this type of, second sector as well, implementation or transformation of material. So there are some in South Africa, but this is more or less the only place where there was a nuclear plant as well established. And he knows about Egypt, who is in the process of constructing this first nuclear plant power. And there is as well commercial reactors. So in other countries in the sub-Saharan part, such as Ghana, Kenya. So this is certainly what you also be aware of. So how do you envision the process as well for using nuclear energy for peaceful purpose in such countries as well, and particularly in terms of training African engineers to ensure African retain as well the ownership of this nuclear resource? So IAEA as well, I guess, is also involved in that.
IAEA,
and the discussion about also touch on issues of knowledge transfer and safety. So Kimal is believing that we should broaden the conversation about African energy security beyond just the use of fossil material. So what do you think?
About nuclear energy, it's my opinion that nuclear energy is indispensable in Africa and should be introduced, because there's no reason why Africa should be the main producer of all that is needed to fuel the sector and the only not beneficiary of that technology. If you look at Niger, it's a shame that companies, I don't want to name any, spend decades, they're exploiting uranium without shares in the dark. Oh, I have to plug my battery. Excuse me, just one thing. I'm sorry about that. I should have done this before. Yeah, so that's something that needs to be fixed and quickly. Now, the strategy for training scientists is something, and technicians, is something that is being addressed now. And again, I don't want to over-advertise the X-Tech Lab, but the X-Tech Lab has started an initiative by the IAEA in order to introduce some capacities, to build capacities in the field of nuclear science in general in Africa. And I think that organizations such as the IAEA should play an important role. But again, the schemes that are available at the IAEA are not well known by many African policymakers, and not even by African academia. They don't know that these skills exist, that bursaries can be attributed to the student. Actually, I was discussing with IAEA the other day, and they said, look, your country is one of the countries that almost never applied to really take advantage of all these schemes. Only few people like Francois have gained access to those programs. But there are many, many programs that can be taken advantage of in order to build capacities in nuclear science. This is one thing. And I think that the initiatives that are being now developed in some countries, you mentioned Egypt, of course, South Africa historically has a nuclear energy program, but Egypt is now in a very good partnership with the Russian company Rosatom, and you have Nigeria, unfortunately, that had a nuclear reactor, but I think it's not in operation now. I mean, the last news I had was that the maintenance was going on, and that it was already several years without any operation on this commercial reactor. Ghana has a program. Rwanda has one. And again, we're talking about the same thing. All these strategies are not thought in a coherent and collective way. We all want to develop our program. Rwanda is developing one, Ghana is doing one. Tomorrow you will probably hear that Benin also want to develop one. But this has not, there's no way, there's no precedent in human history that having those dispersed initiatives in countries that are weak economically, there's no way that they can succeed if there's no collective thinking through and started putting forward a strategy that is common to all.
So a strategy, yeah, but as you mentioned, the IAEA is or have the goal as well, together like with UNESCO and others, to collect the ideas. So again, maybe to stand behind them and to try to promote simple equations, just like the one that you wrote, and to scale it up at the size of the continent.
Yes.
Yeah.
Definitely.
So to be like an incubator as well for those type of solutions. So just a quick mention from the comment as well from Mekela speaking and asking about what do you think the most urgent change needed in engineering education to meet the future environmental and technological demand. So in one sentence, what would you answer for the engineering education?
The most urgent is to be able to train trainers. The most urgent, yes, because I'm sorry to say that I've been able to witness people who are supposed to transfer the knowledge, who unfortunately have the knowledge that is not updated, that is totally outdated by the systemic transformation that occurred over the last few decades. Look, with artificial intelligence, all these things, you have to update your knowledge. So we need good trainers, first of all, and to develop a program in order to train trainers through partnerships. And I think that's the first thing that has to be done, and this is an achievable goal. It doesn't take a lot of money, but it's something that can be done through the schemes that are already existing.
So for instance, what you are doing, so with the XTeX Lab as well, with Marielle, to make some MOOC or some kind of way to register this method that could then be massively distributed as well through internet, at least for whoever as a teacher could use it as well to reproduce in their own country. So that's a good idea and a good example. So we have from Comas as well, Miva, so asking and saying or mentioning, it's more like a comment. So the weak link in Africa, so is technology transfer units and the ad hoc nature of linkage, so between the researcher and the industry. So this is also which industry are existing, which new could be as well implemented, what are the entrepreneurship and the size as well of the needed industry to transform or not. And most research ends up with a publication, another thesis, and a trip abroad. But indeed, how to implement the result of those research?
Yeah.
Simple.
I've given an example, very emblematic, is the bauxite to alumina processing. It sounds simple. It really sounds simple, but it takes a lot of different skills to reach that simple first step processing in order to be able to exploit bauxite. So those industries that are, let's say, emblematic, and I'm taking the example of Guinea, with a program just to incorporate local people in those simple processes would be something that could create a lot of different skills. I just took that example, but I could take many others.
It's a good example, local people investing in their own or with their own capacity. So we have a little high as well. So for you from Samuel Tetek, who was, I guess, one of your colleagues at Tex Lab, and he has been also introducing a course on crystallography at his university, thanks to the good work of the facilities. So he believes that, yeah, we all must be passionate about material science on the continent. Very good comment, Samuel. So then he's got still a question, so which is, but how do we get funding to acquire instrument after the capacity building? So you build capacity education,
yes,
then how do you get the funding?
That's a very good question. That's an excellent question. How do we acquire instruments and how do we maintain platforms that are with cutting edge instruments? I think just doing training. I'll give you one specific example of the XTech Lab, but I think some of the people in the audience can develop on that. You cannot rely on fees in order to maintain such a facility or to acquire equipment. You have to offer services. You have to offer services to industries, to local industry. And those services can be paid for because I know some industry here that send their sample abroad just for simple characterization that could be done locally. If the capacity was there, if not only the data collection capacity, but also the data processing, the analysis, and everything. So this is something that can create a lot of money because in Europe, for instance, most of these platforms now are self-sufficient financially because this platform are able to capture a lot of funding from the private sector or for various industries. And that's something that can be replicated, I think, in Africa in order to get some source of revenue. And we should not be relying on students to pay for their fees in order to attend training because they just don't have the economic power to pay for these extremely expensive training programs. So the industry, that's why I mentioned private-public partnership in my presentation. This is one of the pillars on which we can build scientific infrastructure very solidly. I can tell you that these resources exist. If you know how much one of the billionaires in Nigeria, how much he invests in his platform, you will understand easily that that money is available. We just need to channel it through the right circuit in order to finance this platform. The money is there.
Yeah, but indeed to know that there are also different grant capacity as well to be able to apply to. So that's also the maybe sharing this common language as well. That is important. So then a bit of challenge as well for you from Farah Mazadou, who is asking about this quantum year, because indeed we are in the quantum year of physics, as you know, and this is also in terms of its technology. So at the core, so as material race as well, and at rare material, rare earth, at the new oil right now. So when and so what must Africa do now? So to admit that there is a fresh scramble for its resource to convert its geopolitical moment into a long-term quantum sovereignty. So what would you do for that in terms of how to explore as well those rare earths?
I think I have to give the floor to more better expert than me, because I could say something that is very general, but it's not a subject that I've carefully thought through. But I'm learning from what you're doing, and I think that what is being done, for instance, in terms of material science in general, in terms of developing experimental platform, etc., can be done, because we have a program here that is very interesting, is with artificial intelligence. And I think those challenges are quite similar, that have to be integrated in our new practices. But really, the quantum thing is something that has to be addressed very, very carefully by experts.
Exactly, and maybe this is also the field for the light sources. So around the world, and getting collaboration as well with where those rare earth is coming from, and those worldwide. So light science, the light source as well at the Sesame, for instance, or neutron source, because there is a spin and some more possibility as well for neutron source to attack. So Andrea, for instance, how would you do any kind of experiment so on the development of those rare earths? Do you know about that?
Yes. Yes, it happens. Obviously, we have all the means to do that. But more importantly, since I have the chance to speak, just a second before it's closed, I would like to remember you that the fact that Sesame is exactly the kind of facility that Thierry is speaking of. So it's an international facility, and it crosses borders, which also are very difficult to cross. And so I think that the model can be implemented also in Africa, and it must be implemented also in Africa for large-scale facilities. Obviously, asynchronous is most probably one of the easiest to be implemented with respect to a explanation source, which can take a much more effort to be built, but it is a very flexible tool. It has implications for material science, as we see here, but also for life sciences, for archaeology, for medicine. So it is really a melting pot of different interests and cultures. So everybody knows that I am a strong supporter of the African Light Source Initiative, and I really hope that this can happen in the not too far future.
Yeah, thanks a lot for those so encouraging words, so Andrea. So we maybe one question also from John Angoubar as well, to speak about the fusion with ITER. So do you know anything on any development as well with the collaboration, maybe fusion for energy as well within the African continent? with ITER. So the question is, what lesson can African country learn from the ITER nuclear fusion project in France?
Yeah, a lot of lessons. As I said, this is again the example, a very bright example of collaborative research. And as I said, the main thing is mutualization, and that's the best takeaway that we can have, because you can see that all initiatives that are doing that are coming up with breakthroughs in terms of research and spectacular advances are initiatives that are based on collective effort. So to answer your question, the main lesson is mutualize. Countries who are already stronger than our country individually, economically, find the necessity to come up together, to work together. And, that's the way to go. We, a fortiori, should follow that path and try and build large experimental facilities by putting all available resources together. I can't hear you, Christine.
Can you hear now?
Yeah, yes, now.
Yeah, Leo, is online as well. And just for 1 minute, please. So Leo, could you make as well your comment? Can you speak now? If it's complicated, we can write the question that you have somewhere. Ask to unmute. So Leo, we cannot hear you. Can you unmute? We cannot. Okay, so I think that this will be a lot of valuable additional questions. So we had in the audience as well people asking for exchanging contact, and we will do that. So that is, as Thierry is really open as well to, as you saw, to exchange and to transfer knowledge. So within his team and to
Christine, I have the microphone now.
Okay. So very quickly, please, Leo.
Very quickly, the question refers to what you were saying at the beginning about raw materials. The point, of course, it is important that raw materials are processed at home, but you know that raw materials usually are exploited by big companies, and the percentage which go to the country is very small. I can give you an example in Dominican Republic. The gold mine where I am leaves to the country only 5% of the gold plus 18% of taxes. So this means to be able to process raw material at home also implies a lot of political problems which are not trivial. This is the first comment. The second comment is that today, in a few hours, I will give a talk very similar to the topics you're covering, and I was enthusiastic of listening to the same thing I'm going to say. So that congratulations, it was one of the best talks I've ever heard in my life.
Thank you so much, Leo.
Thank you very much. I totally agree with you with the first comment that you made. Exactly. He has nothing to add, nothing to take away from your comment. Yes, there are a lot of political implications. And unfortunately, things must change.
Exactly. I think this is the main thing. So it's in the hands of our politicians, our governance, but also everyone to be responsible to make any kind of change in the government as well as we can. Now, exchange and collaboration, this is what we try to do. We try to communicate with this physics matter as much as we can with those strategy from the physics point of view, but then we need to encourage so everyone to do the same at their level. So this is like connecting the point, and then we'll make like a coherent picture for an impactful progress as well for this society. So thank you everyone to listen. So we have been quite a lot, so large, spending more time than what we wanted initially, but I think it was so valuable. So, and everything is recorded, so we can skip so any kind of session that could have been a bit long for everyone. So we'll not have time to take any questions or anymore, but thank you very much. So Thierry, so then we had to have spend.
Thank you.
hours with us.
Thank you very much to the organizing committee. Thank you, Andrea. Thank you, Moina. Thank you, Christine, for Stefan, for what you're doing. It's very valuable to me and to many other people. Thank you.
Thank you.
Bye-bye.
And then, so the only thing is now, so I will want to introduce, so the next presentation, as we said, I list a lot of different countries at the beginning. So the next one, so being South Africa. So stay connected and you'll hear a bit more from stores to sustainable solution. So indeed, we are now going to the stores, so, but still this is for Africa, something which is a real added value as well. If you look at the knowledge transfer, so we'll have so Dr. Joyful Molbu, who will be speaking with us on the 28th of August. It's a Thursday, like all the time. So with this framework, so 10 to 11, or maybe a bit more, so that we can stay tuned and learn more and exchange more. So thank you, everyone, so to have connected today. And we'll meet you so in 1 month's time, and everything will be available online by next week. Thank you, everyone, and thank you again, this dear panelist. Bye.
Thank you. Bye.
Okay.